Welcome to my channel. In this first lesson we will talk about resistor. They are the passive compound that most found in PCB. Analog PCB, they come in different shape. We can find those carbon resistor, they are outlet one. Those here are power resistor. They can dissipate more power than small one. The more bigger the size, the most power that can dissipate the resistor. Also we can find this variable resistor. They are called potentiometer. We can find those type are for front panel and those are for PCB. If we need to adjust the voltage, for example, we can use those potentiometer. This one is a linear, it has a linear motion. Also we can find the LDR, it's a light dependent resistor. Its resistance it depends on the light. Those are thermistor. The resistor vary with the temperature. This one is for measuring fluid resistor temperature. This one is a varistor. Its resistor depend on voltage across those pins. Of course, each resistor has a fixed value. For example, this one has 6.8 ohm. This one 10 watt 3.3 ohm. For this one we use color code to determine the resistor. Here is the how to determine the value of the resistor. This is the first digit, this color, this is the second digit, and here the multiplier. For example, here we have 1 and 0, and the multiplier is 2. The red is 2. So we have 1K resistor, 1 kilo ohm resistor. Of course, there are many situations where we need to use resistor. The first and the most known one is the current limiting. For example, here we limit the current in this LED because the LED, if it is powered directly from a 12-volt battery, it will burn. So we need a resistor here to limit the current. The most common use of resistor is the current limiting. We use the resistor to limit the current that flow to the LED. For example, here, if we have, for example, a battery of 12 volt, for example, power source of 12 volt, and we have a resistor and for example, a red LED. So we have here 12 volt, we have here a forward voltage, depend on the color and the type of the LED. For example, for the red LED, we have 1.6 volt, for example, or 1.8, depend on the factory. And we will drive this LED with 20 milliamp, for example. To calculate the resistor, we must, here we have 12 volt, minus the forward voltage. For example, here we have 1.6 volt, and divided by the current. Here we have 20 milliamp. Here we found that we need a resistor for 520 ohm. Of course, we can't find this resistor they come in the A12 series. Most resistor, common resistor, they on the A12 series. So we must choose the nearest one to 520. Here we have the A12 series. So we must use a 560 ohm. We can use here a 560 ohm. For example, if we have a 5 volt here, we have 5 minus 1.6 divided by the current. We found that we need a 170 ohm. Here we will use 180 ohm. Current limiting is not limited to the LED. We can limit the current that flow in the motor. For example, here I have the blower motor for my car, and I use different resistor here to select the speed. For the high speed, they use directly the relay, and for lower speed, these use different resistor. Of course, those resistor must be a power resistor, like this one, not a 1/4 watt resistor. Those small resistors are used for signal, and those to dissipate power, for example. The second use of the resistor is the voltage divider. For example, here, if we have a 5 volt signal, and we need to drive the signal to a microcontroller that accept only 3.3 volt, for example, we can use 2 resistors here. We have ground, and here we have the microcontroller, the input of the microcontroller. Here we have R1, and here we have R2. Here we have 5 volt, and here and the output we found 3.3 volt. We have here the V in, and here we have the V out. We have the formula of the voltage divider. V out equal to V in multiplied by R2 over R1 plus R2. We can fix one value and research the other. The voltage divider also used to control the volume of OLED TV and radio with those potentiometer. Here, for example, we have the RF demodulator that drive the voltage divider, which consists of a potentiometer, and as the output we found the amplifier, the audio amplifier that drives the speaker. When we adjust the volume, when we turn the potentiometer, we adjust the ratio of the voltage divider to adjust the volume. For example, a potentiometer is composed of a carbon, here the carbon, and a wafer. We can measure the resistance. The full resistance here, for example, about, we have continuity. When we switch to the resistor, 870 kilo ohm. At the middle we have 470. So when the wafer adjust the value of the resistor here. Here when we wipe the carbon, we adjust the value of the voltage divider. We can find here a voltage divider used in this circuit, for example, as the input of this comparator, this op amp. Here also we have a voltage divider, consists of R1 and R3. The third use of the resistor is the pull up and pull down. This is for the microcontroller IC. For example, if we have here a microcontroller, we have here an input. We can't leave the input here not connected to the plus VCC or the ground. It will cause a random reading. So if we must use a pull up resistor, and here we can put the push button to the ground. So the microcontroller read always 1, a high logic, and if we push the button, it will connect it to the ground, this input, and it will read 0 or low logic. This is for the pull up. We can use also pull down. Here we have the microcontroller. We can use a resistor to pull down the input and use our push button here. The value might be 4.7 kilo ohm or 1K or 10K. It depends on the input resistor of the microcontroller. If we have a limited power source, we use a high value of this resistor. For example, this schematic, they use 100K resistor with peak basic. Those are for pull up. They are connected to the plus 5 volt. Also here we can find a limited current limiting resistor, 150 ohm. With this green LED, we can calculate the current here. We have here 5 volt, for example, 5 volt minus 2 volt for this green LED over 150 ohm. We have 20 milliamp. In the fourth use of the resistor, we can find the RC timer. This circuit is composed with a resistor and a capacitor in series. We have R and here C. Here we have the voltage input, for example 12 volt or 10 volt. And here we have the output voltage. If we apply a 12 volt or 10 to the circuit, we have here the input voltage, and we monitor the voltage over the capacitor. We can find that it rises until it reaches the maximum voltage. It needs about 5 RC, 5 times R times C. This constant is called tau. Tau equal to R multiplied by C. This circuit is used to, for example, reset the microcontroller at the startup or making an oscillator, for example. Here we can find that in this circuit we can find this RC timer. Here we have the resistance with the capacitor. It's connected to the memory clear to clear the memory at the startup. And also here we can find a timer. We have here R5 and C3. We can, for example, use a oscillator with RC timer. Here we have a Nand gate. Here we put the capacitor, and here we connect the resistor. So when the output is high, it will charge the capacitor until the input began high. The output, it switches to the low level, zero logic. So the capacitor will discharge over this resistor inside the gate. At the output, we can find a square wave here. And the frequency depends to the tau, to the value of the resistor and to the capacitor. In number 5, we found the resistor that used as a shunt resistor. This resistor, it must be at low value, for example, 1 ohm or 0.1 ohm, for example, and it can tell us about the current that flows the circuit. It uses to measure the current or for the protection for our current. We have the Ohm law. Here we have the drop voltage here equal R multiplied by the intensity. So we can deduct that the intensity is the voltage over the resistor. Here we can find an outlet shunt resistor. They use 4 wires. Those 2 wires for the high current, and these for sensing. These 2 are for sensing. Analog ampermeter use the shunt resistor. And we found those different type of resistor. We can find the varistor, the fused resistor, the thermistor. They are 2 kinds, negative temperature coefficient and positive temperature coefficient. And we have the light dependent resistor. We begin with the varistor. It's used to protect the circuit. For example, here they are often used after the fuse. We can find here the varistor. Of course, here we can find the transformer or the bridge rectifier. Here we have the fuse. When we have an over voltage, the resistor drop of the varistor and cause the fuse to blow. So it protects the circuit here. Protect the transformer or the bridge rectifier or the power supply. And in the repair, we need to replace only the varistor. Also, we can find the fuse resistor like this one, often found in cheap transformer. They use a low value resistor as a fuse. We can find the thermistor. The resistor depends on the temperature. In the negative temperature coefficient, the value of the resistor drop when the temperature gets higher. We can measure here, for example, the resistor of this one. For example, this one, at room temperature, we have 40 kilo ohm. When we touch the thermistor, the resistor drop. It have 137 kilo ohm. This one, it needed to determine the temperature of a liquid, might be the water. This one, it used to adjust, for example, the speed of the fan for the power supply. It's mounted to the heatsink. We can measure its resistance. It has 1.6 kilo ohm. When we touch the resistor drop, also we can find those light dependent resistor. The resistance depends on the light. They are used with the movement detector to switch on or off the light. For example, here we have 2.8 kilo ohm, and the value go to the 60 or 70 kilo ohm in the shadow. Now we come to the end of this video. Thanks for watching. Have a nice time.